Okay, so to pick the best titrant chemical, then we will want to use so-called primary standards of a chemical. So then how can a chemical qualify as a primary standard will be from A to E. Well, D is not a qualification. From A to D. So number one, it needs to have a known composition. It makes sense, right? Of course, otherwise how can I weigh out and calculate? Ideally, it's 100% pure. Otherwise, then the impurity or the purity is known accurately. It doesn't change. This is a fixed number. Okay, for your pure chemical, homogeneously distributed, one chemical of this impurity, for example, known purity. Okay, then this fit into your analyte, the equation. So be sure that once you decide on that, there might be several chemicals available for your purpose. Then you need to consider this, right? You want the chemical to react with analyte rapidly. C is that once you get a chemical, the chemical most likely is wet, okay, or is not totally pure because of moisture. So a common procedure is that you put the chemical into oven to dry. Okay, then make sure that the chemical is stable at the oven temperature. Otherwise, it decomposes, will change into a different chemical then. Okay, so this is a consideration. Now, D is high molecular weight. Now, when you use a high molecular weight substance to get your silver, for example, silver attached to an anion become a high molecular weight versus silver attached to a low anion, a low molecular weight anion, then your overall molecular weight would be lower for the same quantity, same number of moles of silver, right? So you want to use a high molecular weight, and therefore you weigh out more quantity. The number of grams becomes higher, so that the relative uncertainty in your weighing will be reduced. Okay. Now think along the same line of let's say, if I use pure silver versus silver chloride for the amount of silver, number of moles of silver I want to get, right? The silver chloride has a higher molecular weight than pure silver. So you weigh less pure silver to get the same number of moles. But when you weigh out less number of grams here, your relative uncertainty, because the analytical balance gives you the same uncertainty. So the relative uncertainty over lower number of grams, then your overall uncertainty will be greater, right? Greater than a higher molecular weight silver chloride. Okay, so this is desirable to have a high molecular weight. Any question with that? Okay, then this is whether the chemical is easily or readily available in the lab. Okay, so cost, safety. So, for example, okay, so here are some common primary standards. For precipitation titration, then the most common titrant is silver nitrate that you are familiar with. Now, then you will say that is silver nitrate qualified as a primary standard? It turns out that is not. It's not. And the primary standard is NaCl or KCl. Okay, so what it amounts to, you need to standardize your titrant. And it's not simply weigh out the number of grams, and dissolve to get your titrant solution. So you weigh this out, and then use this to standardize the silver nitrate solution. So this is the procedure we did, right, in a volumetric precipitation titration. So this is the reason why. So this will be the analyte, and this is what you are familiar with. Now the one we're going to do to continue today is the acid and base titration. Realize that the titrant is sodium hydroxide, right? But the sodium hydroxide itself is not a primary standard. Okay? So you prepare this solution and standardize it against KHP. Okay? So this is your weak acid, the solid acid. This qualifies as a primary standard. So you will use this to standardize for your sodium hydroxide titrant for acid and base titration. So you know this indicator. Then what about instead of base, acid as titrant? Now acid, this is a gas, right? So it dissolves into water to give you the HCl concentration, and that concentration depends on the temperature and because it's volatile and all. So the concentration is 12 point something molar, but then that something is not accurate. Okay, so you use this guy called Thame, primary standard, and to do that, so if you have this available, then you use it. So this is the deal, okay? The actual name. So for us, we call it Thame. It's easier to pronounce than tris. Hold on, then hydroxy methyl bracket, and then aminomethane. So for organic folks, we really enjoy that. Okay, so acid and base, right? So you analyze the base, then use a different indicator, methyl orange, because of the endpoint region. Okay, then complexation, right? We will do this in the future. So EDTA, with ideally with zinc. This is the indicator. Redox titration. This is a strong oxidizing agent, the purple solution that you've seen before. Then primary standard, ideally, is this guy, arsenic oxide, but that is toxic for this guy. Okay. Indicator. Okay. So those are the common ones. So you realize, when you understand the meaning of primary standard and understand not all chemicals are qualified as primary standard, then you realize the meaning of standardization to your titrant.